I hope you might have already well acquainted with the division algorithm or Euclidean algorithm for two positive integers. Now I am going to, what you can say, whether this division algorithm used for two positive integers, can it be applied to polynomial? We will discuss that here. Now we can consider the division algorithm for polynomials. Now recall the division algorithm for positive integers, that is, given two positive integers p and q not equal to 0, there exist or we can find two integers k and r such that p is equal to qk plus r, where r is either 0 and r may be greater than 0 but necessarily less than q. Now, can we apply this algorithm to polynomials? Now, let us see. Let us consider px is equal to x cube minus 3x square minus x plus 3 and gx is equal to x minus 1, and here we are instead of p we have taken px, a polynomial. Instead of q we have taken gx, another linear polynomial which you have considered. And now you can see, let us see here, if x is equal to 1, then p1 is equal to 1 cube minus 3 into 1 square minus 1 plus 3, that is 1 minus 3 plus 1, minus 1 minus 1 plus 3, that is equal to 0. This implies that 1 is a 0 of px, and therefore x minus 1 is a factor of px, and hence you can write down px is equal to x minus 1 into qx, where qx is called quotient. How we can get at this quotient? Quotient qx is equal to px by x minus 1, that is px by gx. Now you can see this quotient is obtained by dividing px by gx. Then what is the procedure? For the division, now you can look at this procedure. I would like to put it step by step by taking one particular example. Here, procedure for division of polynomial px and gx, like that is general polynomial we can think of, but I am going to consider a particular polynomials. Now example, divide px is equal to 3x square plus x square, 3x cube plus x square plus 2x plus 5 by gx is equal to 1 plus 2x plus x square. The first step, I would like to put it as step 1, write px and gx in the standard form. Px is already in standard form, so no need to write once again standard form. But gx is not, so therefore gx can be considered in a standard form. X square plus 2x plus 1, this is a standard form. Now I would like to go to the second step by dividing this px by gx. What is the quotient? To do this one, we can see here step 2, divide the first term of px by the first term of gx. First term of px is a 3x cube and first term of gx is a x square plus 2x, x square. That will give the, what you can say, 3x will give the first term of the quotient. What about the other term of the quotient? We can see in the step 3, 4, etc., which I am going to find out whole of qx, that is the quotient. The step 3 suggests that multiply the first term 3x of the quotient to gx, that is x square plus 2x plus 1, that is 3x into this 3x cube plus 6x square plus 3x, and subtract this in px, we get minus 5x. I demonstrate this here. Here I would like to demonstrate here, that is 3x cube plus x square plus 2x plus 5, that is the first term of the quotient, that is 3x, and divisor is x square plus 2x plus 1. Multiply this one, this 3x cube plus 2x square, 2 into 3, 6x square, 6x square plus 3x, and subtract accordingly in the step 3, minus, this is minus, and these two terms are getting cancelled, minus 5x square, minus 5x square, minus x plus 5, and this I would like to call it as a P1x. P1x, let us say. Then we will go to the next step, step 4, and again divide first term of P1x. First term of P1x is minus 5x square divided by the first term of divisor, that is that will give minus 5, and again I would like to subtract this in this, repeat the same procedure as in the case of the step 3, and this I would like to multiply this one by minus 5x square minus 10x minus 5, subtract these two, this is plus, this is plus, this is plus, this is 9x plus 10. And here look at this. I would like to stop this procedure here. Stop this procedure. Why we have to stop this procedure? Because degree of 9x plus 10 is less than degree of gx, and therefore we have to stop here. And now therefore px equal to 3x cube plus x square plus 2x plus 5 is equal to 3x minus 5 into x square plus 2x plus 1 plus 9x plus 10. Simplifying this, you will get the what is that? Px. Here this is called quotient. This is what is that called? Dividend. And this is divisor. And this is a remainder. And therefore this can be written dividend equal to, I can write down this as this is quotient into divisor plus a remainder. And therefore I can put it that division process here in terms of a statement as in the case of what is that Euclidean algorithm. Thus given any two polynomials px and gx, where gx is not equal to 0, we can find qx and rx such that px is equal to qx into gx plus rx, where rx is either 0 or degree of rx is less than degree of gx. This process will continue like this. We need not stop at step 6. If it is degree of the remainder is more than degree of gx, then continue as in the case of step 3, and you should continue until you get the remainder whose degree is less than degree of the divisor, and therefore division algorithm for positive integer also holds good for polynomials.